Dimension of physical quantity. Now we know that the physical quantity, it may be derived units or it may be the standard international units. So any physical quantity, it is always expressed in terms of the fundamental units. Then fundamental units are mass, m, l, length, capital T for time, A for ampere, K for temperature, Kelvin, CD is for the luminosity, intensity, and mole is the. So we can express any physical quantity in the powers of the fundamental units, and that is known as the dimension. So dimension of a physical quantity is expressed in the powers of their fundamental units is called dimension of the physical quantity, as I explained to you last time. So now what is to be remembered for writing the dimensional formula for any physical quantity? Number one, pure number, fractional number, or pi, or any trigonometric function, sin theta, cos theta, they are unitless and we will not count for writing the dimensional formula. Second, the same dimensional quantities can be either added or subtracted. So the dimensional formula is written in capital bracket. It is m power a, l power b, t power c, a power d, k power, and so on. So here a, b, c, d, it can be positive or it can be negative integer or even fractional also. So the dimensional equation, this is the dimensional formula. Dimensional equation is, if we write in left hand the physical quantity and right hand side is the dimensional formula, then in left hand side we will have a physical quantity and in right hand side we will have the dimensional formula. Then this will known as the dimensional equation. For example, if we have to take the area, it's a physical quantity, area is equal to length multiplied by length. So L square. So we will write M0, L2, T0 and within the bracket. So this will be the dimensional equation of area, and this is the dimension of the area. And its unit will be equal to M is 0, T is 0. So it will be equal to square meter or meter square. That will be unit. So we will take some physical quantities and we will write their dimensional formula and their units. First we take area. Now what is area? Area is a product of length into breadth. Length is measured in the capital L and breadth is also length. So it will be equal to length into length, will be L square. It will be here L into L. So L is square. So there is no M, so we will put within bracket M0, L is square, T0. And unit will be equal to meter square. If we take the second quantity, volume. Volume is equal to length multiplied by breadth multiplied by the height. Length, breadth, these are all the measurement of length. So L into L into L. It will be equal to L into L into L. This will be L cube. So its dimension will be equal to m0 L cube T0. So unit will be equal to meter cube. Now we take the density. What is density? Density is mass per unit volume. So we divide mass by the volume. So mass is m and volume is, we find the value is, so m divided by volume is equal to L cube. So it will be equal to, the dimension will be equal to m into L minus 3 into T0. So the unit will be equal to mass a kilogram and the volume is meter cube with the minus 3. So the unit of density will be equal to kilogram into meter minus 3. Then speed or velocity. Speed is distance traveled in per second, or velocity is displacement per second. So displacement or distance are measured in the length and time is measured in t. So it will be equal to L divided by t. So its formula is not depending on m. So m0 L and t minus 1. So the dimension will be equal to m0 L t minus 1. So its unit will be equal to meter per second, or meter into second minus 1. This will be the unit of the velocity. Then acceleration. Now what is acceleration? Acceleration is rate of change of velocity, means velocity divided by time. The velocity, unit of velocity is Lt minus 1 and we divided by t. So this will be equal to Lt minus 2. So its unit will be equal to m0 Lt minus 2. So unit will be equal to meter per second square, or meter into second minus 2. Then what is the force? Force is product of mass into acceleration. Mass, we know the mass is m, acceleration we have find, so it will be equal to mass multiplied by acceleration is equal to Lt minus 2. So the dimensional formula will be equal to m ka power 1, n ka power 1, L ka power 1, T ka power minus 2, and unit is Newton. Either you write capital N or Newton. N is small, N-E-W-T-O-N. So this will be the unit of force. Next physical quantity is momentum. What is momentum? Momentum is mass multiplied by the velocity. Now we know the dimension of mass is m and velocity is Lt minus 1. So the dimension will be equal to m into Lt minus 1. The unit will be equal to kilogram into meter per second. Now next is your work or energy. Work or energy. What is the work? Work is a product of force multiplied by the displacement. So we know the unit of the force and we know the displacement is distance. So the amount, this will be equal to, force will be equal to mLt minus 1. So here we can write this is equal to mLt minus 1, this force multiplied by the distance L. So it will be equal to m into L square T minus 2. So this will be minus 2, not 1. So force is mLt minus 2 multiplied by L. So mL square T minus 2. So this will be the dimension of energy as well as work, and the unit is joule. We write capital J or small j UL is joule. So we can write in both the ways. Now what is power? What is power? Power is rate of doing work. Means work divided by time. the value of work we have found. So work was equal to m L square T minus 1 divided by minus 2 divided by T. So it will be equal to m into L square T minus 3. So the power which is equal to rate of doing work means work divided by time. We substitute the value of dimension of work ml square T minus 2 divided by the time. So it will be equal to ml square T minus 2. The unit will be equal to joule per second. Joule into second minus 1, or we can say joule per second, or it is also known as watt, W. Watt in the honor of James Watt, who invented the steam engine. Then we will take the, what is the pressure? Pressure is force per unit area. Now we know the value of force. Force is equal to mlt minus 2 divided by area L square. So it will be equal to ml minus 1 into T minus 2. So the pressure will be equal to m the pressure will be equal to ml minus 1 T minus 2, correct. So here we can write the value of the dimension of this thing. Now what is moment of force? Moment of force is force multiplied by distance. So unit of force is mlt minus 2 multiplied by distance L. So its unit will be equal to m L square T minus 2. So this will be the moment of force. This is also known as the torque. The unit of torque is same as that of the energy or work. But energy or work is a scalar quantity, whereas moment of force is a vector quantity. And we can write this is as a Pascal A or Newton per meter cube. Square. Meter minus 2 into per second. So the unit will be equal to, moment of force will be equal to kilogram. We can also write kilogram into meter square second minus 2, or Newton into meter square, because this is the Newton into meter. So we can also have this unit as a Newton into meter. ये भी लिख सकते हैं. This unit is Newton into meter. Now gravitational constant. Now gravitational constant is, gravitational force is F is equal to capital G m1 m2 bata r square, where m1 is the mass of one body, m2 is the mass of the second body, and distance between these two is r. So the force, gravitational force F, which was given by Newton, is equal to G m1 m2 bata r square. So capital G will be equal to F multiplied by r square divided by m square. Now we substitute the value of dimension of force. Force is mlt minus 2 into length square r square r square. So L square divided by m square is m square. So if we solve it, it is m minus 1 into L ka power 3 into T minus 2. So m minus 1 L cube T minus 3, or the unit will be equal to Newton. This is force Newton into meter square divided by kilogram. So it is Newton meter square per square kilogram. So this will be the unit of gravitational constant. Now, what is the impulse? Impulse is a force for a small duration of time, and impulse can be expressed as force multiplied by the time. So force is mlt minus 1 multiplied by time. So force is mlt minus 1 multiplied by t. So it will be equal to mlt minus 1. So the impulse will be equal to Newton into second, because the force is Newton and time is second multiplied. So the unit of impulse is Newton into second, and its dimension will be equal to mlt minus 1. Now stress. Now elasticity. What is the stress? Stress is force per unit area. So force divided by area. The unit of force is mlt minus 2. Area is L square. So we divide it. So it will be equal to ml minus 1 into t minus 2. This will be the dimension of stress, and unit will be Newton divided by meter square. So Newton into meter minus 2. This will be the. Now what is the strain? Strain is change in length divided by original length. So both the dimension of change in length is also L, and original length is capital L, same. So this will cancel. So there is no unit, it is dimensionless. So we will write M0, L0, T0. So it is dimensionless, or there is no unit for stress. Now the elastic constant. Elastic constant is ratio of stress to strain. Elastic constant, there are three types of elastic constant, we will read later. Then stress divided by strain. The strain, we know that it is equal to ml minus t2 and divided by L. So it will be equal to ml0 t minus 2, and the unit will be equal to Newton per meter. Sorry. This is equal to ml minus 2. It is Newton into Newton per meter square. The unit of the stress will be same as that of the elastic constant, because the unit of strain is dimensionless. So the unit of stress and the unit of the elastic constant, they are same, and that is Newton per meter square, and dimensions are ml minus t minus 2 for both. Now what is the surface tension? Surface tension is a tension on the liquid, and it is force per unit length. Surface tension is divided force per unit length. So we know the value of force, mlt minus 2 divided by L. L will cancel. So its unit will be ml0 t minus 2, and unit will be equal to Newton per meter. So that will be the unit of surface tension. Now surface energy. Surface energy is work per unit area. So work is ml square t minus 2. We have derived it. Divide L is L square. So L square will cancel. So it will be equal to ml0 t minus 2. And unit will be equal to, work is joule and area is meter square. Joule per meter square. So it will be equal to joule per meter square will be written. Now coefficient of viscosity. Now viscosity is also a property of liquid. Viscosity, the viscous force is equal to eta. This is N, this is eta into A, area of cross section, into velocity gradient, that is velocity divided by L. So N will be equal to, eta will be equal to, the viscosity constant will be equal to F into R divided by A into V. We substitute the value. Then force is mLT minus 2 into R is length, area is L square, and velocity is LT minus 1. V is velocity. V is not the volume, V is velocity, LT minus 1. So we solve it, it will be equal to mL minus 1, T minus 1. So the unit of coefficient of viscosity will be equal to kilogram per meter per second. So kilogram per meter per second, this will be the coefficient of viscosity. Now angle. Now angle is arc bata radius. Arc divided by radius. Arc is measured in the length and radius is measured in the length. LL will divide. So it will be equal to M0, L0, T0. But we know that from the SI unit, it is not having any M, L and T. These dimensions are all 0, 0, 0. So it cannot be expressed in the meter, kilogram and time, and it is measured in the radian. So radian is the unit and it is the subsidiary SI unit, and that is the radian. Now what is the angular velocity? Angular velocity is angle divided by time. The angular displacement per unit time. So omega is the angular velocity. Omega will be equal to angle divided by time. There is no unit of angle divided by time. So it will be equal to m0 L T minus 1, and unit will be equal to radian per second. Similarly, what is the angular acceleration? Similar to linear acceleration, this is angular acceleration. Angular acceleration is angular velocity per unit time. Let's say the linear velocity or velocity was distance but a time, and angular velocity is angle but a time. So here omega will be equal to, as angular acceleration will be equal to omega by t. So 1 by t d. So it will be equal to m0 L0 t minus 2, or its unit is radian per second square.